Hello students, let's learn an important term used in coordination chemistry, that is chelate ligands. So what are chelate ligands? So the definition is di or polydentate ligands can bind the central metal through two or more donor atoms and form ring complexes. Such type of complexes are called chelates, and those ligands are said to be chelating ligands. So didentate ligands means they are having two donor atoms, and polydentate ligands are having more than two donor atoms. So didentate ligands are having two donor atoms. So these type of ligands can bind the central metal through two donor atoms. So in the case of polydentate ligands, it is having more than two donor atoms. So it can bind the metal through more than two donor atoms. So in such cases, the complexes are in the form of ring. So ring complexes are formed in this case, and these complexes are called chelates or chelate complexes, and those ligands are said to be chelating ligands. So actually didentate ligands and polydentate ligands are chelating ligands. For example, En. En means ethane 1,2-diamine. Ethane 1,2-diamine. So it is an example of a bidentate ligand. It is an example of a bidentate ligand. Another example for chelating ligand is EDTA. Ethylene diamine tetraacetate. Ethylene diamine tetraacetate, that is EDTA. It is actually a polydentate ligand. It is having 6 donor atoms, or it is called a hexadentate ligand. So it is a hexadentate ligand, or it is a polydentate ligand. This also form chelate complex. And En or ethane 1,2-diamine, that is a bidentate ligand. This also form chelate complexes. So En and EDTA are the two common examples of chelating ligands. I will draw one ring complex with bidentate ligand or a chelating ligand. If the complex is like this, PtEnCl2. So this is actually a chelate. Why it is called a chelate complex or chelate? Because it is having En. So En is a didentate ligand, or it's a chelate ligand. It's a chelating ligand. So there is a chelating ligand in this particular complex. So it is actually a chelate complex, or it can form a ring complex. So it is in the form of a ring. So we can draw the ring is like this. So these are the two Cl, and then comes the En, that is ethane 1,2-diamine. So actually this is ethane 1,2-diamine is CH2, CH2, so NH2 2 times. So this is the formula of ethane 1,2-diamine, and these two nitrogen atoms, these are having lone pairs of electrons, and these two nitrogen atoms are the donor atoms which can bind the metal. So this, in this En or in this ligand, these two donor atoms can bind the metal. So this is the structure, and this is in the form of a ring. So actually this is in the form of a ring. So it's a ring complex since it is having a chelate ligand En. So chelate ligand En is a didentate ligand. So this complex is a chelate complex, and this is in the form of a ring. So ring complexes are actually having a chelate ligand. And one more thing is to be noted in this topic is this type of complexes are more stable. So chelate complexes are more stable than ordinary complexes. since these are having a ring structure which is more stable. So chelate complexes are more stable. So the stabilization is due to the chelate effect. The stabilization of this type of complexes is due to chelate effect. We can say in that way also. So the chelate effect gives the stabilization of that complexes. So we can say the chelate complexes are more stable than ordinary complexes. So this is about chelate ligands.